One is going to get into building a real, very large-scale game environment in the browser and some of the challenges and techniques that go into that. So I'll pass the mic over to Charlie Key, who's going to enlighten you.
Good morning. So I'm Charlie Key. I work for a company named Modulus. This may be a very different project if you understand what Modulus does. We do application hosting. So we got involved very early with a company called Think University to talk about how they could build a virtual environment that was scalable and really kind of available everywhere. So what is Pillow Pets World? So Pillow Pets World is made up of kind of two major pieces. One is the website, and this is where people can come in, and mostly kids, and hopefully, and hang out. They have their own virtual room where they can put items, chairs, flowers, whatever they want. But the more interesting part to us is the virtual world. So this is a massively multiplayer environment where kids can come in and play games, visit other places in the world, and talk with each other, and do that kind of. It's very Club Penguin-esque, Moshi Monsters, if you're familiar with any of these. Now, that has its own challenges in itself. So on the website, pretty straightforward. It's a straight-up Node.js app. It's got built with CoffeeScript. I know that's bad in this room. That was not anything I had a choice in. And then Express, and then it kind of pulls some data from the back end using Wrestler, which is a module that makes pulling API data kind of simple and easy. Now, on the other hand, we have the virtual world. Now, the virtual world came in with these very lofty goals. One was that it could be played and was available anywhere. Now, what's that mean? That means being able to play it on your desktop, your mobile phone, your tablet, anything with a screen at almost any size. Now, real time, this is self-explanatory, especially in this kind of MMO world. Characters are going to be interacting with other characters and talking and moving around. Scalable, as we continue to bring on more and more users, it needs to be scalable, large, and expandable. Now, this is an interesting one. What we wanted to do from the very beginning was architect this world to be able to add on new locations, new games very easily with little to no downtime, and to be able to expand the virtual world quickly. So what's this kind of look like? So on the front end, it's built using a Canvas HTML5 graphics engine called Pulse. It's all 2D. We kind of communicate back and forth using some regular HTTP, but also Socket.io. This gives us kind of that real-time feel to it. It gives us WebSockets with these fallback mechanisms. And then on the server, we have Node.js. And then kind of behind that as a communication layer almost between servers, we use Redis, which handles very high throughput very nicely, can scale out by spinning up multiple Redis servers and distributing kind of our messages across different places. So I'm gonna show off a little bit of the Pulse game engine real quick, just to kind of show you the kind of things that it does. And this is just a demo from the site with Pulse.com, and it's simple Mega Man here. See if I can play on this computer and look up there. So very normal 2D graphics engine, has capabilities to do sprite sheet animations, and then it also has the ability for like physics. So we can do some interesting stuff here, and that allows us to have a good base layer on the client side to have a nice graphics engine. And So that's what handles on the front end. That handles the graphics. That handles the drawing. All of these simple pieces that we're going to need to be able to have our game. So what does the virtual world kind of look like? Well, this is the moon in that actual virtual world. So you have your character, and he can walk around, and you have some animations, and you have different kind of things that you can do. And then you can go play games, you can go to other locations, you can go back to the world, kind of visit different places. This is where it always goes wrong. But so that's kind of the virtual world there, and you can visit different places in the world. So there's Rome in here. There's 5 different kind of locations, each with 3 different what we call rooms. So let me see if we can jump into Rome real quick. And these are all different places where children can go and play around and visit different things. And more games will be added on. So that extensibility is very important for us at this point, is being able to add these new locations kind of quickly and easily. So let me jump back to PowerPoint here. That'd be Keynote. So that's a little bit of what the front end looks like. So it's got this pulse around everything that's going on there. And so the front end design, so we looked at this and we said, how can we make this an extensible kind of modular kind of setup where these rooms, these games all live in this same programming paradigm. So what we decided to do was we created what we call actions. Now, actions can do one of any several things. One is play a sound. One is play an animation. Now, these would be what we call a local action. They just happen in the browser. They happen locally and on the client's machine. Now, remote actions are things like go to a new room. So if I want to go from the New York City to the New York subway, or I want to go from the moon and play a game. Now, these are the kind of things that require getting data from a server and processing that information. So we had this kind of scheme that we wanted to go with. And what does this start to look like on the server? Now, there's a lot of lines and a lot of blocks here, but I'll try to describe it pretty well. So on the client, we have the client, and it's got its browser. What we have is we have this server that kind of handles what happens when you ask for an action. We call that the orchestrator. The orchestrator then will tell you what other server you're going to connect to. So if you want to go to New York City, you do an HTTP request to orchestrator and say, I want to check out New York City. And the orchestrator will come back and say, all right, connect to this server, and it will talk to you and tell you about New York City, and you'll now communicate with it. Now, the same thing works with rooms and then games. So, but all of these things kind of have to have something that connects them behind it, and that's Redis. And it's used very simply. It's used to, when a new room comes online, when a new game comes online, when it starts up, it pushes out a notification that says, I'm online and I'm available to do this. Now that goes through Redis Pub Sub, and now any orchestrators listening will be updated and say, now I know that someone can do this new thing. So I'll dive into a little bit of the request flow a little bit more. So this is kind of what that looks like at a very high level. So the client comes in and he says, I want to go to New York City, so give me a New York City server to connect to. The orchestrator says, okay, connect to this server. Now the client knows where it wants to connect to. It sends a request to that server, and that server will check its identity, check a few kind of authentication type things, and then say, okay, you're now connected. Now at this point, we've got a pretty standard socket I/O connection, and we have our own protocol to talk between the server and the client. So at this point, the server, the room, in this case New York City, will respond and say, all right, I know that you're connected. Here's some information that tells you what New York City looks like. So we've gone with a very simple, it's almost legible, a very simple kind of JSON configuration to say what these places look like. So the first piece is we have our assets, and that's up at the top in the area where it's blurry, of course. But we have different types of assets, and images, sounds, and JavaScript files. Now, these images are going to be sprite sheets, big sets of atlases, similar to what Max was showing earlier. Very same kind of setup. And then we have sounds. These are sounds that are going to play in the background, play on an action, different kinds of stuff. And then different sets of JavaScript that we may need. So it may have a module of JavaScript that handles chat communication or different pieces like that. So all of those are kind of preloaded when you go to that room. So it automatically, the client-side software will automatically figure out what should be done with these and will preload them so you've got access to them on the client. And then we jump into what the layout should look like. And this is, there's a lot of little pieces in here, but it's pretty straightforward. You have things, you have backgrounds, you have animations, and you have kind of where players can move around. And this is all defined in this layout here. We have a sound that will play when you go into the room. And we have where the player will start when they enter the room. And then we have layers, and each layer actually will sit in its own canvas layer in its own HTML5 canvas, and that will add in different things. Like this one, in this case, will have a background based on this asset up here. NYC main BG, NYC main BG. And then we have different animation layers. So as we saw let me jump back over here. So as we see in this one, we have the fountain that's animating. So that's just a sprite sheet animation, and we have these little buttons that are also animating. And they have different cursors. So all of that's kind of in this animation layer. And then we also have where the player can actually go. And this is all set up by bounds. This is just a polygon, a convex polygon in which they can walk around, and you can set that to any number of points you want, and then that will automatically handle like running into an edge or running into a corner or any of those pieces. That's automatically handled by the client. And then we have different actions. One is the scavenger hunt pieces, and these pieces are used in the scavenger hunt game. Let me see if I can load up here. So the scavenger hunt is one of the things you can do inside of the game, and you go and find these different pieces throughout the world. And those are actions that are just set up. And it all kind of works. It's funny that this morning has all been about kind of modularity and games, and this is very much a modular kind of virtual world. So that's kind of what it says when, New York City looks like this, that this is that configuration file. Now you have your character in a room, you know what it looks like, you're spending time there. Now we can move around, and what happens then is the client will move, and it will tell the server, I've moved, and anyone else in that room will get updates and notifications that you've moved, and the same thing with chatting. And then you'll receive real-time updates on the client side that someone else has moved. So, kind of, what do we mean by scalable, and how does Node.js kind of fit into this? Well, we know Node.js is really good at doing small applications that are I/O bound. So it's spending all of its time over the wire. It's talking to a external API or a database, and Node.js worked perfectly for what we're doing. Mostly the servers are going to be taking in a little bit of data and then sending it out to the other people in a room, or talking to the API all the way on the back end that handles giving users their score, adding points to their account. And so that worked perfectly. So now we have Node.js is the right technology here. How do we break this up and so we don't end up with a mammoth application? What we did was we said, well, what if we took each one of these pieces and we broke them out into their own application? So your orchestrator is its own application, and now even more broken down, these rooms, so the main city, New York City, the main Rome, and the subway, they're all their own applications. Now, what's this do for us? This does a lot of different things. So one is that we can scale these independently of each other using, so it's running in this cloud environment, and we can look at what's going on with each one of these rooms and scale it independently. So if San Francisco is the most popular place, we can scale up San Francisco without having to worry about scaling up the entire world. And that does a lot of things for us and for the client, and that makes it easy for them to do and makes it cost efficient. And with these stats on these individual rooms, we can identify which ones do need that scaling up by looking at how popular they are. So extensible. Now, we looked a little bit about what that configuration kind of looks like for a room. Well, that configuration can be updated and changed in real time, and then the next time someone loads the application, it will have a new action available or a new room is available, because all we have to do is update the configuration for the world. So all we have to do is add a new location to the configuration for the actual world. And now we've got a new place where someone can go, and then that has its own configuration. So we can update these things and add games and locations dynamically. Now that also lets us be able to do more interesting things with different kinds of remote actions. So if we wanted to have a service that got updated when you clicked a button, what we could do is that would just send off a new action that sent a little bit of data to a service, and then now that service can be brought online in the same kind of manner as the rooms and the games. So that's really the base of what makes this a very expandable, modular kind of virtual world. Now, this has worked very well for us in the early stages. It's been out for a couple months, and we're slowly ramping up new areas, so new locations, new games, and it's been very easy to not only add them in, but it gives us the ability to have other people work on different pieces and build new games and not have to worry about how every other piece is working. And that gives people a very quick time to ramp up to be able to be useful in the virtual world. And that's kind of all I got. I'm Charlie Key. You can catch me online. And if you want to check it out, the world is actually available at pillowpetsworld.com. Yeah. Yeah. So each room is kind of its own server, and what happens is each one of those servers kind of has a limit to how many people can join into that room. And whether it's 15 or 20, that's kind of configurable. So one person connects, and on the server, it kind of keeps a pool of who's in the room. So when it connects, it puts you in the most full room, because we didn't actually want to put it in the least full place, because you want to have other people you're communicating with and you're playing with. But say there's only one room, so you get dropped in that room. When a new client comes in, it says, okay, this room's got a person, I'll drop you into this kind of pool of players. And that's not all that, seriously complicated on the server side. You have basically have kind of an array of who's in the room, and then when an action happens, it will go through and it will say, I need to send this to all of these other people. And we use some disconnect kind of, so Socket.io has a disconnect event, and you can use different things.